Hello, everyone. This is technically future Mr. Wiseman from the class, but past Mr. Wiseman from if you're listening to me or not. So, I do want to say, hey, first of all, time's a little crazy. I want to bring back and remind you guys of the the scientific prefixes that you are going to need to put to memory. There's giga, mega, kilo, deci, centi, milli, micro, nano. And it is all based off of the base. Now, the base could be a lot of different things. The base could be grams, it could be meters, it could be liters, it could be seconds, depending on what we're looking at. And yes, that is a G. I know my G's aren't the most clear G's, but is what it is. On the back side, there is a easier way to see your numbers, right? So right here, we still have the base. And like I said, the base could be grams, it could be meters, it could be liters, it could be seconds. And then we have the ones that we need to know. Giga, mega, kilo, deci, centi, milli, micro, nano. And this one gives me a read of where things are towards the base. The larger number it is the larger prefix, holds so many bases. So a giga holds a 1 billion of a base. A mega holds 1,000,000, kilo holds 1,000, and then we break down into smaller groups. Deci, I can fit 10 deci bases into one base. Centis, 100 bases into one base. Millis, 1,000 bases into one base. Micros, 1,000,000 bases into one base. And nano is 1,000,000,000 nano bases into one base. Now, we started talking about scientific notation. Lord have mercy. We started talking about dimensional analysis. And we said that there are 4 steps, and they're very well outlined on the top of our paper here. That was our classwork/homework. So the first thing that we always want to do, so our steps, is step number 1. We want to write down all equalities, let's say A, qualities used in the question. Step 2, we want to rewrite the question. Step 3, we're going to multiply by the equality in a fraction. And in that equality, we're going to have whatever we want on top, whatever I'm getting rid of, on bottom. And then number 4 is that we're going to multiply through the problem and round to the correct number of sig figs. So I'm going to put this off to the side, and we'll use this to answer questions 1 and 2, which we did in class together. Excuse me. There we go. Now I'm going to keep these steps beside me, so that's why I could see these things pretty easy. Now, the only equalities that I want you to memorize at this point are your scientific qualities here. So really, on this side of the page, on the back side, because it gives me how many, if it's large, how many bases fit into the mega, giga, or kilo base, and then how many deci, centi, milli, micro, or nano bases fit into the one base. These are the ones I do want you to put to memory. That's going to be super important. But let's look at some, we'll do the one-step problem, the two one-step problems that we did in class, and we'll also look at number 8, which we did in class as well. So number 1, I have 2.5 yards, and I need to figure out how many inches are in that. Okay, so the first step, so I'll take a look at my rules. First thing I need to do is I need to write down the equalities I'm going to use in my question. Now, yards being an empirical measurement, I can look up here. I see 1 yard holds 36 inches. So step 1, so I want to write down my equalities. So I have 1 yard is equal to 36 inches. I'm only using one equality, so I only need one equality. Step 2, I'm going to rewrite my question. So I put it down here, 2.5 yards. Now, I did say you can put this in the form of a fraction if it makes it easier, because we're doing a lot of stuff with fractions. So sometimes it's just easier just to make everything a fraction. So that's step 2. Step 3 is to multiply by the equality in the form of a fraction. And how I want to put that fraction can go one of two ways. It can either go 1 yard over 36 inches, or 36 inches over 1 yard. These are my two options. Now, good news is that I have a very easy way of figuring it out. Whatever unit I'm starting with has to be in my denominator of my next fraction. Also, whatever I want to end in has to be in the numerator of my next fraction. So I want to get rid of yards and keep inches. So I'm going to choose this fraction here. 36 inches over 1 yard. And I multiply through. Now in class, I actually wrote out equals this and blah, blah, blah. Or we can leave it just like this. And I want to make sure I cancel out my like terms, because if I have yards in my numerator and yards in my denominator, they cancel each other out. In homework, in the quiz, in the test, I want to see us crossing out those units. If it's in the numerator and in the denominator, cross them out. So that leaves only one unit for our answer to be in inches. 2.5 times 36 times 1, divide by 1 inches. If I pull out a handy dandy calculator here, 2.5 times 36 gives me 90 inches. Now, key thing is that my answer here has such the same amount of sig figs as my answer does up here. So I count 2 sig figs here, and if I'm doing the math, I only count 1 sig fig. So I have to think of how I can get this number into 2 sig figs. And the easiest way to do that is scientific notation. Plus 1 inches. Now I have 2 sig figs. I start off with 2 sig figs. I ended in 2 sig figs. That's what we're going to expect from you. So let's go ahead and do number 2. Number 2, we had 950 grams equals how many kilograms? Now, in order to figure this out, because I know we just got these sheets, I can't expect you to memorize something I literally just gave you. So make sure that when you're doing these questions tonight, that you're doing it with your SI prefixes chart. If I leave it over here, it gives me the equality. So I find I want kilo. I find kilo here. I see there's 1,000 bases for 1 kilobase. So Step 1 is I write out my equality. 1,000 bases equals 1 kilobase, or 1,000 grams equals 1 kilogram. Step 2, I rewrite my problem. 950 grams. I'll turn that into a fraction just to make life easier. Step 3, I need to pick which fraction I want. Remember, I want over what I'm getting rid of. So my two versions, I could rewrite my equality as a fraction. It's either going to be 1 kilogram over 1,000 grams, or 1,000 grams over 1 kilogram. Take a look at what I have. I'm starting off with grams in my numerator, so that means my denominator of my next fraction has to have grams. Lo and behold, that's the one I want. 1 kilogram over 1,000 grams. Now, step 3, my last step, I multiply through. My grams cancel each other out. My final answer is going to be in kilograms. Technically, I count out the ones. So now it's just 950 divided by 1,000 kilograms, which equals out to 0.95 kilograms. So next thing I want to do is make sure that my final answer has the same number of sig figs as I started out with. Count 1, 2. Trailing 0 doesn't count because it's a trailing 0, no decimal. 1, 2. Leading 0 doesn't count because leading zeros are never significant. Therefore, I don't have to do anything. It's just 0.95 kilograms as my final answer. All right. Now, lastly, we did one of the multi-step ones. So with a multi-step one is that we're having two or more steps to get to my final answer. Now, I chose the metric one because I feel that those are the easier ones to do. Whenever we're doing a multi-step, excuse me, metric dimensional analysis question, you always want to go to the base first. So if my question, go to the base first, then go to what you want. So I see that in order to go to the base, I have to go from milligrams to grams. So I'm going to go milligrams to grams, and then from grams, I'm going to go to centigrams. But I always want to go to the base first. Whenever I'm jumping between two different SI prefixes, I always want to go to the base first. I can easily get mixed up if I don't go to the base first. That's why I want you guys to always go there first. So if I'm doing number 8, 0.035 milligrams, and I need to convert that into centigrams. So I need to pull out my sheet here. I see M, so one base holds 1,000 millibases. So for my equalities, 1 gram holds 1,000 milligrams. I go back to centi C. One base holds 100 centibases. So 1 gram holds 100 centigrams. So I have my equalities. I just have to put them in the right order. So first thing I do is I rewrite my question, 0.035 milligrams. And like I said, turn that into a fraction if you want to. You don't have to. That's the only thing right now you don't have to. You don't have to turn it into a fraction. I need to figure out which one's going to get me to the base. So I take a look. I'm starting with milligrams. I have milligrams, centigrams. I want to use the milligrams. 1,000 milligrams. All right. So I want in grams right now because that takes me to the base. And now from the base, I want to go to centigrams. So I have grams in my numerator. That means my next fraction has to have grams in the denominator because I want to get rid of it. And then I'm going to put the 100 centigrams up top. So I can cross some things out. Grams cancel each other out. This 1 cancels the 1 out. So it's going to be 0.035 times 100 divided by 1,000 centigrams. I'll take out my handy dandy calculator again. 0.035 times 100 gives me 3.5. I'm going to divide that by 1,000. I have a final answer of 0.0035 centigrams. Oh, and I don't see it. There we go. Now I just go check. I started off with 2 sig figs. I come down here. Now I count 2 sig figs. I don't have to do anything to my answer. Nope, technically if I want to, I can convert that to scientific notation. 3.5 times 10 to negative, because we got a number smaller than 1. 1, 2, 3 centigrams. And that's it. So gang, I want you to go ahead and I want you to take a stab at the other questions. So if I'm looking at here, like number 9 here, I need to go to years to hours. Well, I can think about this. How can I break years down? Well, I know that there's 1 year holds 365 days, right? If I was to go down even further, I know 1 day is made up of 24 hours. And that gets me to my 2 steps. When it goes to kilogram to decagram, again, you want to go from kilogram to gram, gram to decagram. Millimeters to centimeters, millimeters to meters, meters to centimeters. Molecules to liters, go ahead and use these 2 equalities up here. Now, we are going to be using a lot of these 2 equalities a lot in Unit 6. So if you don't put it to memory now, don't worry about it. It's not going to be a big problem. But that's what I want you to do. I want you to knock out as many of them as you can. Try to get all 22 of them done. We're going to review them in class next time. So that's it, guys. So you guys did great. I hope you did well in the quiz. And I will see you in the near future. Hasta luego.